Good evening, y'all. What follows is going to be a demo of a section of a talk I'm giving this Thursday at the Chicago Node meetup about orchestrating async in JavaScript. And this is the kind of flagship demo. Inbox radio, the functionality of it is very simple. What if you could hear what your inbox sounded like? For example, I've got a friend named Greg. He and I play in a band together, and sometimes he records the tracks that we have made, and he sends them to me in emails. So imagine that I do a search for Greg, and this hits the Google API and notices that there are emails from Greg that have attachments. And imagine that it downloads those attachments and plays them as they become ready. But it has it all straight in the console. Why? Because, retro. So, I'll show you a look at the code of this, and I'll actually, break it down how it's built. I'm not going to live code the whole thing, but it uses React to render to the console. That's right, I said React to render to the console using a package called Inc. It uses observables throughout, like this whole presentation is about, and it also functions as a state machine. So you saw a few things in that demo. It went by pretty fast, so I'm going to actually explain them bit by bit. So the user searches, right? So that's an event. This is all about events. And in response to a search, we hit the Google API, and Google will tell us that certain messages match. But those messages actually don't contain the attachments. In fact, we have to do a call to get the message body, the attachment ID, at which point we can begin to download the attachment. Now, this is clearly async. It takes some time, but eventually the attachment will finish, at which point we can play the file, begin downloading the next attachment, and eventually a played file results in a complete event. And that basically is the workflow of the application. But the anatomy of a program like this is that there is a how section and a what section. So what is done? Well, we just start, okay? How does that get done? Well, let's first look at the implementation of the start method. It does a clear of the console. It creates an event of the type user search with a payload consisting of the specific search term, and then the Google API requires that you, in order to match attachment containing messages, it requires that you pass this. So that's it. We process the search and we update the view right away. The next section that we'll see is actually everything up to the top of the file, which I'll go over in more detail soon. But it is the configuration of what to do upon each event. But there's an interesting thing about this architecture is that I didn't know how to work with the Google API. I didn't know all the calls that would be needed in order to work with the Google API. So I actually made stub implementations. So this is the thing that really helped me to get around the problem of I want to write the application and I want to get it right without ever having to sit there reading the Google API documentation. I want to get a feel for how the application works. I want its parts to work relative to each other before I go and say, here's the exact API call to get the Google attachment. So this was absolutely an epiphany for me when I wrote an application in this style and then merely wrote a real module, and I'll talk through both of these in detail in a second, but wrote a real module that essentially conformed to the same specification. And then pretty soon I had the equivalent of, running this without the demo equals one parameter. Let's take a look and see if this is actually going to work right now for actual emails sent to me by Greg. Yep, these are real. These are real songs that I work on with Greg. Oh, good, and a fun error. Yeah, it wouldn't be a live demo if there wasn't an error. Come to my meetup and see lots of live errors. So again, stubs that return observables. Here are the functions that need to be exported from either the stub file or the real file. The real file exports the same functions, only it's not a stub implementation. So this file up here is the orchestrator, where it pulls the implementation either from stub or real depending on that environment variable, it requires the view, and then it gets to work. So let's get to work on here. So the reason that we see new events in our logs is because of this filter, which, like I said, runs on every action, and it receives the action as an argument, and then we apply some indentation and formatting to the action, put it in the log, and then the view renders this. This is not a React meetup, but I will show you the view really basically. There are boxes, there are colors, there is text, there is a queue, and there are logs. And it's a very straightforward React implementation, but I don't want to explain the React too much. All you basically need to know is that this file exports an object called props. It uses that props to render, and it exports a function called updateView, in which it will trigger that render. All right, let's move back to this orchestrator. I talked to you about the filters. The filters are for simple, and by simple I mean synchronous, not asynchronous, not API calling, simple consequences. When you get an event that says play, well, just take the attachment that you're playing and put it in the title field of now playing in props. That's what allows this thing up here, which is now dash 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 because you're not playing one, to take on the name of a song. Here, I'll just run it into the background. It's fun. The attachment ID, all of these filters, they mutate props. Okay, so this is like, you could call this Redux Lite. You could roll all this into one reducer, but I wanted to keep it very much event driven. Okay, and then again, filter every single action. This function is going to be run on every action. You can provide a string, a function, or a regular expression to decide whether the handler is going to be run on every action. So these filters accomplish updating the view. The other type of way of attaching behavior to your application, the way of growing your application modularly, is by using these on calls to say when a user searches, you should get matching headers from search, and all of those headers should be turned into events of type Google Message header. Then, of course, you're chaining these on. So you can see how I generated my state machine documentation, because a user search results in Google Message headers, a Google Message header results in attachment IDs, and so forth. So this kind of takes the same signature as a filter. There's a matching. Oh yeah, that was some nice TypeScript explanation from the type doc. You see that it takes basically the same API, a criteria for which to match an event, and then a handler which returns an observable, and then a type that explains how to process that observable as new actions. But downloading an attachment is different, right? You saw here that we had net attachment start and net attachment finish, and we had no overlap between starts and finishes. In other words, we downloaded them serially. And the download attachment function has no special logic to deal with handling things serially. You write the download attachment function in its purest form, and I'll show you that in just a second, and then you just say concurrency serial. And process, of course, is named for the Antares API method, or the RX helper method, that says if you want to just send a single action through the chain of filters and handlers, just send a single action through with process. If you have an observable of multiple actions, you can pass it through with subscribe. So I'm going to start with a very simple one, get matching headers from search. And I think it'd be nice to show this alongside the orchestrator file so that you can see how get matching headers from search corresponds. Basically, we want to return observables from these handler functions. And they take as an argument the action that is triggering them as a field of an object, same as filters. And then it's going to return an observable. Now, an observable like we said, needs to be subscribed to, but you don't need to manage subscription calls. The agent will manage those for you. So all you have to do is say, in response to a user search, here is how I get an observable of messages that match it. So from the action, do a list messages. That gets you a promise for the first page of matching messages. It's more consistent with the observables philosophy to return the messages individually, because each one of them will turn into one of these Google message headers, right? So you see individual events, and that's one of the jobs of these handlers, is to take arrays of things that you might get from an API and kind of shred them into individual events. And so then you see the message ID is the field from the Google API. That becomes the body of this. If we go to here, you're seeing message IDs. This is a real song from my inbox, by the way. I'll tell you the story about this in a little bit. Are there any questions on this right now? Because I want to get down to a little more tricky one, the download attachment. And you see these download attachments, we know they're going to take some time. We're going to write them to a temp file and then tote that temp file's name along so that we can play it. But it's going to be downloading serially, and the only thing we need to do in this function to allow serial processing to happen is to say when we're complete. If we don't say that we're complete, this agent has no idea when to start the next one. So we're seeing a couple of advanced techniques in here. One, specifying the entire action and saying process results as opposed to this. And then two, specifying the serial mode, where you don't really write this differently, but you do have to say when you've completed or errored. So this one is actually, there's probably a bug here where if I were to actually get a net attachment error, I would have a bug if I didn't also say complete. So that's it. I mean, it's actually very, very smooth sailing to add functions that all kind of follow this format. They return observables. They call next on the observables as events happen. They either put the name of the event in the payloads that they're sending out through notify next and call process results true, or they omit the type and they just return the payload, and then they get assigned the type over here. So like, for example, get audio attachments. You'll see this observable is putting a complicated payload, but it's not including the type or payload fields. Those get put in place by this framework. So I think I should finish on a story. So what this does is it allows me to basically have a radio station of any music in my inbox. My father-in-law does music, and so I actually asked him to write the processional. He didn't know he was writing it because he's an improv guy. So I had to videotape him playing it and then give it to my friend Ben, who is a viola player and arranger. And I corresponded with Ben on writing the processional for our wedding that my wife walked down the aisle to with her father. So that is in my inbox, and I'm going to show you a search where I hit the inbox for processional. It's going to find a few messages from my friend Ben, and you'll hear the pizzicato strings of the processional before the legato violin comes in. And then when the bride appears, so that shows that music. It's now playing processional. It'll switch to recessional. I'll let you hear a piece of that as well. But so this is like very real to me, this idea of streaming. and having like a radio station out of different slices of my past whose audio is just sitting there preserved in my inbox. But for you all, I think what's important about this type of coding, this type of orchestration, is that it's actually far, far simpler. Each one of these is atomic, synchronous stuff. And then each one of these this is a way of doing async, where your application is just isolated into these little nuggets. It actually accomplishes the goals that I had of allowing you to stub or simulate complicated functionality prior to knowing how to use those APIs. And it lets you grow your application in layers with very little rewriting. It was really an epiphany for me to learn that it is possible to code this way. I don't think I'm ever, for my personal projects, going to code any differently. Here's the recessional, and let me say thank you while I leave that on. I'd love to see you Thursday night. I hope you can make it.